Hello guys and girls, ladies and gentlemen. In some of the previous videos, I promised that we would look at the header of the main method in a bit more detail later on. And you got it. That's what we're gonna do in this video. We already know that main is the name of the method and void its return type. We also know that it takes a string array named args, which stands for arguments, as a parameter. It's public and static that we haven't covered yet. Public is an access modifier. Access modifiers define visibility of class members outside the class. I know that probably doesn't make much sense to you, so let me show you a couple examples that demonstrate how access modifiers work. But before that, I'd like to make sure it's clear what a class member is. A class member is a variable or method that belongs to the class. Know that only variables declared directly inside a class are members of that class. In other words, a variable declared inside a method of the class is not a member of that class. In NetBeans, member variables are green, while non-member variables are black. Now, if this doesn't make much sense to you, you got it. Please refer to the previous videos before proceeding with this one. And now back to access modifiers. Let's now start NetBeans and create a new project named public static. In the public static.java file, let's delete the comments and space out the code a little. Now, if I type system.out and wait, we will see that out is public. This out is also a variable that belongs to the system class. In other words, out is a public member of the system class. And because it's public, it's visible here in the public static class, even though it belongs to the system class. If out wasn't public, we wouldn't have been able to go system.out. NetBeans would yell at us that it cannot find symbol. Before I show you another example, let's take a look at other access modifiers available in Java. There are 4 access modifiers in Java: public, private, protected, and default. The methods that we created in previous videos, getUserInput and doMath, all have default access modifiers, meaning when you don't specify the access modifier at all, it's set to default. As mentioned already, a public class member is visible outside the class it belongs to. On the other hand, a private class member is not visible outside the class it belongs to. Class members with the protected or default access modifiers are partially visible outside the classes they belong to. In this video, we will only cover the public and private access modifiers. To see the practical difference between public and private access modifiers, let's add a Java class to the public static package and name it simply myClass. In myClass, let's declare one public variable and one public method, like this. Now let's switch back to the public static class. We will be switching between files and classes a lot in this video, which might get overwhelming. And if that happens, don't panic. Just pause the video, take some rest, and then come back. Now inside the public static class, let's instantiate myClass. Then add the dot operator, and if we type my after the dot, we will see both myInt and myMethod on the list. Now let's switch back to myClass and make myInt and myMethod private by changing public to private, like this. If we go back to the public static class, we will no longer see myInt and myMethod on the list of available members. And if we try to, say, call myMethod, NetBeans will yell at us. Why? Because it's now private and not visible outside myClass. Now back to our main method. It's public, so it's visible outside the class it belongs to. As simple as this. Some of you might ask, why would we want to restrict visibility of class members outside the class? Well, there are several reasons why we might want to do that, and here's one of them. Imagine we have a class, myClass, that has 2 public int variables, a and b. Say for whatever reason, the value of the variable b depends on the value of the variable a. Specifically, b is always half the a. Now, how do we make sure that every time we modify the value of a, the value of b gets updated accordingly? We can add a method that would do that, and the method would look something like this. Now, if we instantiate the class and call the setA method passing 6 as a parameter, it will set the value of a to 6 and the value of b to 3, which is just what we need. However, since the variable a is still public, we can also modify its value directly, which might result in something unwanted. And to prevent that, we should make the variables a and b private, so that there is only one way to change their values by using the setA method. Alright, let's now talk about static members. Remember, objects in OOP are made from classes, and normally, every time you create an object, that object gets its own set of member variables. And every object can assign different values to its own set of variables. This allows for some variability among objects of the same class. Say we have a class that has a member variable that represents color. Now, if we create 3 objects of that class, each of the objects will be able to have its own color. And even though these 3 objects have different colors, they are still objects of the same class. This means that objects of the same class do not have to be completely identical. However, objects do not always get a copy of all of class member variables. Some member variables belong exclusively to classes and do not replicate in instances of those classes. Such member variables are called static. So when we create an object, that object receives its own set of non-static member variables of the class. Non-static member variables are also called instance variables, because every instance gets its own copy of that variable and gains control over that variable. One of the practical meanings of this is that static members are accessible on the class, while instance members are only accessible on an instance of that class. Doesn't sound very practical, does it? Let me show you an example. First, let's make my method public again, add a main method to my class, and switch back to the public static class. Since the main method is static, we can access it on the class. Simply put, we can call the main method using the name of the class only, like this. However, if we try to call my method the same way, NetBeans will yell at us because my method is non-static and must be called on an instance. Like this. Of course, if we make my method static by adding the word static to its header, we will be able to call it on the class. Another example is the scanner class that we used in one of the previous videos to take user input from the console. Does anybody remember what method we used for that? Right, we used the nextLine method. Because the nextLine method is non-static, we had to instantiate the scanner class to be able to use the method. And because the variable out of the system class is static, we do not need to instantiate the system class in order to be able to use the variable out to print text to the console. So if you want to access a static member of a class, you do not need to instantiate that class. And if you want to access an instance member of a class, you have to create an instance of that class first. Now let me show you an example that demonstrates another difference in behavior of static and instance members. Let's switch to my class and add a private static variable named myStatic. Let's now delete my method and main method and add 2 public void methods instead. One will increment my int variable, the other will increment my static variable. Also, let's add 2 public int methods. One will return the value of my int variable, and the other will return the value of my static variable. Now let's switch back to public static class and create 2 myClass objects and store references to the objects in variables. If we call get and getStatic methods on both m1 and m2 and print the return values of the method calls, we will get 4 zeros, which is expectable. Before we continue, please make sure you understand what this code does. If you don't, please refer to the previous video before proceeding with this one. Now let's call increment and incrementStatic methods on both m1 and m2 before the println method calls, like this. And if we run this program, we will see that the value of my int variable of both m1 and m2 is 1. which is expectable because we incremented it once, from 0 to 1. But the value of my static variable is 2 for both m1 and m2. Why? When we call the increment method using m1 or m2, it's only my int variable of m1 or m2 that gets incremented. However, because my static is static and belongs to my class, not to my class objects, when we increment my static using m1 and when we increment my static using m2, we increment the same my static variable. In other words, static variables are sort of shared among all instances of the class. Because of this, it's generally not recommended to access static members on an instance, even though technically it's not forbidden. Before we move on to a more practical part of this video, let's summarize what we have covered so far. Access modifiers define visibility of class members outside the class. There are 4 access modifiers in Java: public, private, protected, and default. Public members are completely visible outside the class. Private members are completely invisible outside the class. Protected and default members are partially visible outside the class. Class members can be static and non-static or instance. A static member belongs to the class itself. A non-static member belongs to an instance of the class, not to the class itself. Static members can and should be accessed on the class. Instance members can only be accessed on an instance. Every instance of a class has its own copy of each of the instance member variables. However, there's only one copy of each static member variable, which makes static variables sort of shared among all instances of the class. So the main method that serves as an entry point to a Java program is public, which means that it's visible outside the class, and it's static, which means you can call it on a class. Now let me show you one of the possible usages for static members. Let's close the public static project by right-clicking on it and choosing Close, just to put it away. What we're going to do is we're going to put our Form A and Form B programs together into a single runnable program. Currently, we can only launch one of them, and if you want to launch the other one, we have to do it separately in NetBeans, which isn't very convenient. I guess it's not super clear what I mean, so let me show you the end result of this video. At the start, the program shows Form A. And if we press this Form B button, Form A disappears and Form B appears on the screen. And if we press this Form A button, Form A appears on the screen while Form B disappears. If you don't have this GUI project that we started a couple of videos ago, don't worry. Just go check the previous videos, make these Form A and Form B classes, and come back here. We can wait. So first of all, we need to modify both Form A and Form B. We need to add a button to each of the forms. Let's start with Form A. First, we need to expand the form, like this. Then we should select all the components on the form, like this, and move them downward to free up some space for the new button. And we can now add the button that will open Form B. Change its text and its variable name. Let's repeat these steps for Form B now. Now let's add an event handler for this newly added button. To make a JFrame form appear or disappear, we can use a certain instance method of the JFrame class. Any ideas what method I'm talking about? Right, this one, setVisible. So if we call setVisible method and pass it true as a parameter, the form will appear. And if we pass it false as a parameter, the form will disappear. Sounds simple, but setVisible is an instance method, which means that we need to know the reference of the form object that we want to hide or show. One way to get such reference is to create a new object, which is done here. Let's try this approach first. So when Form A button is pressed, we need to hide Form B by calling setVisible method, like this. And then we create a new Form A object and make it visible. Let's do the same for Form A now. And run it. Well, seems to be working. But do we really need to create a new form object every time we press Form A or Form B button? I mean, why create a new form when we can show the same Form A or the same Form B? For one, creating a new form every time is wasteful, and it also can lead to some other technical issues that we will not discuss here to keep it as simple as possible. So why did we choose to create a new form object every time the button is pressed in the first place? We needed a reference to call setVisible method on, and class instantiation is one way to get it. What would be another way though? Right, we can store the references to both forms. We can create both Form A and Form B objects at the start of the program and store their references. The question is, where in code do we do that? In Form A? In Form B? Or maybe in some other class? I say we do it in the GUI class, the one that hasn't been used at all so far. Here's what we need to do. We copy this code from the main method of Form A and paste it in the main method of the GUI class. Let's also clean up and space out the GUI class. For now, just like we had been doing with the header of the main method up until recently, we're going to ignore this weird looking code, this invoke later method and such. You got it, to keep it as simple as possible. So in addition to Form A, we also need to instantiate Form B. We now need to assign the references to these two form objects to respective variables, and the variables must be visible in Form A and Form B classes. In other words, we need two variables that are going to be visible outside the GUI class. This means that we need a public variable of the type Form A and a public variable of the type Form B. Now inside the main method, we assign references to the form objects to the respective variables, like this. Two issues here. First, we cannot call setVisible method here because we want to store the reference to the Form A object. So for now, let's get rid of the setVisible method call. The other issue is that non-static variables cannot be referenced from a static context. It means that we cannot use non-static variables inside static methods. Since the main method is static, the FA and FB variables must be static as well if we want to use them inside the main method. No problem, let's make them static. Finally, let's make the Form A object visible by calling setVisible method on FA, like this. Now we need to make necessary changes to the Form A and Form B classes. Let's switch to Form A and look at the Show Form B event handler. When we press the button, we do need to hide Form A, so we should keep this setVisibleFalse method call. But instead of creating a new Form B object every time we press the button, we will be showing that Form B object that we created in the GUI class. In other words, we need to call setVisible using the FB variable declared in the GUI class. How do we access it? Easy. Since it's public and static, we just go GUI.FB and make it visible. Let's do the same for the Form B class now. Now let's run our program by clicking this Run Project button, and I will explain why in a bit. So if we run our program, do some math in the Form A, then switch to Form B, do some math here as well, and if we now switch back to Form A, we will see that the math we did in Form A is still there. And it's there exactly because it's the same Form A object, not a new one. Now, why did we click the Run Project button this time? Why did we not run a form by right-clicking on it and choosing Run File as we did before? Does anybody remember why we didn't use the Run Project button in the first place? Right, we didn't use it because when you click the Run Project button, by default, NetBeans calls the main method of the class that was added to the project first. And in our case, the class that was added first is the GUI class, which didn't have any code before. Now that we added some code to the main method of the GUI class, and now that we do want that code to be executed at the very start of the program, we in fact should run our program by clicking the Run Project button, or by running the GUI class directly. If we try to run Form A or Form B directly, the navigation buttons won't work. The program will throw an exception because now it's the main method of the GUI class that instantiates the forms and stores references to those forms, and it has to be executed first for the program to work properly. If you're having difficulty following the content of this video, please do refer to the previous videos before proceeding with this one. Now, some of you might ask, why do we call setVisible method here without any instance? We do not need to provide an explicit instance here because we want to hide this form, the one that we are writing this code for at the moment. But if we want to be more explicit, we can add the keyword this before the setVisible method call. This is effectively a variable that stores the reference to the object itself, and is accessible only from inside the class. In other words, every object in Java knows its own reference, which is stored in the variable this. If you don't get it at the moment, it's totally fine. I'm sure you will eventually get it as we continue using the keyword this in the future videos. So now we can use both Form A and Form B without launching them separately in NetBeans. Moreover, we can run this program without NetBeans at all. Let me show you what I mean. First, let's press this Build Project button. In the console here, you should be able to see a file path. Let's open it. If you don't know how to do that, please Google Open File Path Windows if you're using Windows, or Open File Path Mac if you're using Mac. If you're using something other than those two, I'm pretty sure you do know how to open a file path. So this is what you should be able to see. And if you now double-click this GUI.jar, it will open just like any other app, without NetBeans or anything else. You still need to have JVM though. Before we wrap up this video, let's take a look at what we did to put the two forms together into one app. We have our Form A and Form B classes instantiated inside the main method of the GUI class. Why did we choose the GUI class for this? Because currently its main method serves as the entry point to our program. In other words, by instantiating Form A and Form B classes inside the GUI class, we make sure that the forms are created at the very start of the program. When the GUI class has instantiated the forms, it stores the references to the forms in public static variables, FA and FB. Later on, when we press the Form B or Form A button on one of the forms, the form object accesses the reference of the other form using the GUI class and makes that form visible. This is just one of possible ways to use static variables. It's not necessarily the only way to combine several forms into a single multiform program, but it works fine for our GUI project. So congratulations, we have created our first multiform program using Java. Even though the program itself is hardly of any use, it has been a good learning practice, I believe. This practice has also helped us build up enough knowledge and programming skills to move on to more complex, but at the same time more useful programming, which we will get to shortly. In the next video, we'll start working on a Tetris game, a game that I believe most of you are familiar with. It might sound trivial, but trust me, it's going to be way more complex than anything we've done so far. And I'm sure it's going to be as exciting. Can't wait to see you then. Bye bye.